Hi guys, so this is chapter 4. It's not a very long lecture. Let's see if I can get it within the 10-minute window I need. So chapter 4 actually kind of continues from the parts of the cell which we talked about. You should see some of the terms from that lecture. You should also notice some terms that you may be familiar with, some you may not, but it shouldn't be too bad. So passive transport. So one example is something called diffusion. Diffusion is the movement of substances from areas of high concentration to areas of low concentration. So the difference in concentration of a substance is called the concentration gradient. So this concept of diffusion, going from an area of high concentration to low concentration, is related to one of the themes of biology we covered in the first chapter. So it is related to actually maintaining equilibrium, which is related to the term homeostasis. So if I'm writing this down and I'm talking about it, putting stars, y'all should know what that means. Diffusion is movement of substances. Osmosis, I don't know if you know the movie Osmosis Jones, that name. It refers to the movement of water to maintain equilibrium. And there are 3 different examples of solutions you should be familiar with. So let's get started. So hypertonic, meaning hyper like hyperactive. Hyperglycemia, so increase, that's all it means. So let's say this is our cell, and that's kind of our cell. This is the container it's in. So what happens is that actually it's more concentrated on the outside. There's more stuff on the outside compared to the cell itself. So what's going to happen is that water will leave the cell, and unfortunately when that happens, the cell will shrink or shrivel up. In a hypotonic, like hypo, so it's opposite of hyper, so it's lower. So you have your cell, and then you have the container it's in, or the solution that's around it. So the hypotonic solution means that the solution, in comparison to the cell, is actually less concentrated. So notice there's more stuff, more whatever you want to call it, in the cell compared to the water itself or the solution. So what happens is that water from outside the cell will actually come in, and when that happens, again trying to maintain that equilibrium, the cell will lyse, or you can say it will swell up, lyse, explode, however you want to say it, because it's trying to maintain that equilibrium. So isotonic solution means that with water and the cell has the same concentration of stuff, so it's not as opposite as the other 2 examples. So the water kind of leaves, goes in and out, no big deal. Another example of diffusion is through ion channels. Some ions cannot fit or cannot go through a membrane because of selective permeability, which we talked about last chapter or the chapter before. So an ion channel, it's a transport protein, and it allows ions to pass through without coming in contact with the nonpolar interior of the lipid bilayer. So basically, if a channel is open, it allows ions to kind of go through. And the reason why this is considered diffusion, or this is passive, even though you think you're using a channel, it's going to be active because that requires something. The important thing to remember that if it is passive, it is going from an area of high concentration to an area of low concentration. Low concentration. So a couple of ions that use ion channels. Potassium, which you should know, Ca, calcium. This is sodium, a sodium ion, and Cl is chlorine, but if it is an ion, is actually chloride. The inside of a cell is typically negative, and so what's going to happen is that the positive ions are most likely going to go inside a cell because it is more negative on the inside. So that's part of the passive transport, diffusion, etc. So a positively charged ion is more likely to go into a cell through that ion channel because it's going from an area of more positivity to an area of less positivity, so more negativity. Facilitated diffusion uses a carrier protein that binds to a specific substance on one side of the cell membrane and release it on the other. So this is not specifically for ions itself, but for other types of molecules, if you will. It helps move down a substance in its concentration gradient. So another thing to remember about this is that this does not require energy. No energy is really needed in the broadest of terms because it's going from an area of high to an area of low concentration. Active transport. So this is the opposite of it, opposite of passive transport. So the difference between this and positive transport is that energy is required because you're going against the concentration gradient. So basically, even though this area is high and this area is low, normally things, if we're passive, are going down this way. However, with active transport, with movement against a concentration, you're actually going this way. So you actually need energy in order to make that happen. So they do have carrier proteins as well, but again, they function to move stuff against their own gradient. So against basically it's going from an area of low concentration to an area of high concentration. So one example is a sodium-potassium pump. It's kind of famous, but it's like a well-known example. So this pump transports 3 sodium ions out of a cell and 2 potassium ions into the cell. This energy that is needed for this to happen is supplied by ATP, and it transports sodium and potassium ions out against their gradients. So I know I'm not really going into this in too much detail. We'll watch a video when we're in class on your day. So we'll get into more detail then. So movement in vesicles, this term should look familiar. It was from we talked about parts of a cell, the rough ER, Golgi, all that type of stuff. So some vesicles are used for movement of a substance into a cell. So this term into a cell is endocytosis, into a cell. Exocytosis is outside of a cell, kind of like endothermic and exothermic. Ooh, that was horrible. Endocytosis into a cell, exocytosis out of a cell. So some examples for endocytosis are vesicles that may fuse with lysosomes, so that means they're going to get destroyed, broken down, etc. Exocytosis for movement outside of a cell. This is the protein modification by the Golgi apparatus. So kind of like we said, this is kind of like autocorrect. Somebody said that lysosomes are, you can say they're kind of like a garbage disposal, breaking down things, etc. But then this is just another example showing what it looks like. A membrane receptor protein. So a receptor protein binds to a specific signal molecule and enables the cell to respond to the signal molecule. There are 3 different examples. One of the things that can happen is that there's a change in permeability, and binding of a signal molecule causes an ion channel to open up. Second messengers may be formed inside the cell, and it acts as a molecule that says, hey, let's amplify the signal of the first messenger, the first molecule, if you will. And this allows the permeability to change or to activate enzymes, which we talked about last class. And last, these may act as an enzyme as well. And what they do, as we know, is they help speed up a reaction. All right, guys, lecture is over. Hit that like and subscribe button.